Okay, this is a video on operations with functions. I think that the most confusing part of this is when you're given two equations in general. So let's talk about if we're given that f of x equals 2x squared minus 3x and g of x equals x squared minus 3x plus 2. So we can do a couple of things here. The first thing we can do is we can just say maybe find f plus g of 1. And that would basically mean that I find f of 1 and g of 1 and then I add them together. So f of 1 is 2 times 1 squared minus 3 times 1. It's negative 1. G of 1 is 1 minus 3 plus 2, which is 0. So therefore f plus g of 1 is negative 1. Let's get back up here. This is negative 1 plus 0, which is negative 1. So that can be for any value, and it can be for any operation: subtraction, division, multiplication. Then we get into in general. So if in general if I wanted maybe f plus g of x, I would take f and add it to g, and then combine like terms. So 2x squared plus x squared plus 3x squared, negative 3 minus 3 is negative 6, and then f plus 2. Now the domain of this is just negative infinity to infinity because this is a polynomial. It gets a little more complicated when we do other operations. Like maybe we do f divided by g of x. So in this case we would have 2x squared minus 3x over x squared minus 3x plus 2. So this is a rational function. I want to do the domain, so I want negative infinity to infinity. X squared minus 3x plus 2 cannot be 0. So I would need to factor this. X minus 2, x minus 1. So I get that x cannot be 2 or 1. I could do the same thing. I could flip it. I could say g over f. So let's do that one next. G over f is x squared minus 3x plus 2 over 2x squared minus 3x. It's very similar. Now I have something different in the denominator. So I'm going to say negative infinity to infinity, 2x squared minus 3x cannot be 0. For this, I'm going to have to use the GCF, so I'll factor out an x. I'll have 2x minus 3 cannot be 0. So this tells me x cannot be 0 or 3 over 2. In the case of multiplication, I don't think it's necessary to multiply out all the polynomials unless you want to do it just for fun. So if we had to do maybe fg, you would keep them in parentheses. And the product of two polynomials is also a polynomial, so the domain of this will just also come out to be negative infinity to infinity. The book will frequently multiply these out, but like I said, you can leave your answer like that. That is sufficient.